By the way, it just meant might not matter for anybody. I think you all were here, but remember when the video was screwed up at the beginning and I tried to reset and get it going? Well, I didn't. I got the first video, but not the rest of the class. It was a pretty good one, which I was reluctant to. There's a lot of good info on there, I think, but oh well. So anyway, no video for last time, so I'll start with today.
Change in capital technology alters output's production function. Now Alfred's output is given by Q equals 10 K to the 0.7 out to 0.3. If Alfred employs 3 workers, how many machines will he have to use to achieve the production level we found in A? What happens to the isoquant?
Talk about the isoquant. All right. Who wants to tackle that? What did you guys come up with? What's your thoughts?
You're just plugging in like you have the same quantity, you're still at 20, but what used to be, if we were holding a constant or whatever, you're plugging in 2 units of labor, 3 units of labor, 1 unit of labor, and then finding out how much capital and then drawing your new isoquant.
Okay, so the shape of the production function has changed, right? The contours have changed. Whenever we tweak those parameters of the exponents or something else, we're kind of bending it, forming it, reshaping it. And so the key is that the quantities held constant still. So with this problem, if we had an isoquant that looked like this and quantity was equal to what, 20? So if the Q20, let's call it, is the isoquant, and we now tweak that function. We're going to still hold quantity constant, but once you plug in these levels, the same levels of labor, let's just, and I'm not staying exactly with the problem, but let's just say that there's 6 units of labor and 3 units of capital. That's a point on the isoquant that generates 20 units of production. And now we tweaked that function, then this point is going to possibly be here now, here now, here now, here now, you know, whatever. Somehow that point has changed, along with other points along the contour, which would cause it to become possibly more complementary or more substitutable. Getting back to what we talked about last time, if it's flatter or steeper. And with this one, we just kind of plugged and chugged, right? Yeah. So then you can kind of map out if where that new isoquant would be relative to that. So what Q equal 20? If it happened to go, what did it end up being, more bendy or more flat? Flatter. So what?
The difference between like if it's a shift or if it's like a curvature change is whether the quantity is more constant or not?
Yes, essentially, that's right. Yeah. Because a shift, then we get into the similar axioms that we had for consumer preferences. Isoquants can't cross each other. You know, there's a whole family of curves, and the family could end up kind of doing something like this, possibly, depending on the technology. The technology is embodied in the functional form, what those exponents are and what maybe some other, whatever that mathematical equation is, that determines the shape. And so yes, you're absolutely right. So because we held it fixed at 20, that's what's giving it more bend or shape, as opposed to a shift. A shift is always at a higher quantity. Good distinction. Okay, anything else? Were you starting to make the connections between the previous chapter and this chapter? I mean, it kind of flowed very similar. Okay. So, why don't you turn those in? And we will get into my copier. Wasn't too great this morning. So this next chapter is on cost. grade you? Chelsea looks tired this morning. Huh? Don't know why? Too much of a break. Winter break. Alright, so we're into cost curves. So who remembers the cost curve formulas? Go ahead, spew them out. I know you love them and need them. Let's start with total cost aspect. Total cost. Yep, from principles class. That formula, I had that kind of combination of things to have memorized. Everybody get one? Good. Total fixed equals, I'm sorry, total cost equals total fixed plus total variable. So what was important about that formula? Talk to me about it. So that hopefully we got it memorized, but more importantly, we kind of know what we're talking about. What is significant about what's going on with that equation? What have we done? How have we parsed it out?
Long run and short run?
Possibly, yes. So it's tied to that to some degree, but not necessarily.
You have one that's just held constant, and the others are there, obviously there.
Constant with respect to what? That's the key, that's the linchpin to this whole thing. Nope. So we've separated cost into two categories. What's the linchpin that separates the two? Total fixed cost, total variable cost. Add them together, you get your total cost of production. What's the thing that's separating these two? It's a very simple thing that you're going to go, oh yeah, I should have known that. It's not time, because this is at a slicing time. I'm sorry, what'd you say? The plus sign does separate them, correct. Point taken. The quantity is the biggest thing, and this is kind of the linchpin for the whole chapter. Rests on your understanding of that. What about quantity? No. What does this one mean? Yeah, more quantity means more variable. And what about over here? That stays the same. So if I produce nothing, zero, what do I get rid of all my costs? No, I still got fixed costs. So that's the linchpin for the whole chapter, is Q equals 0. And the reason that's important is tied in partially to long run, short run, but not necessarily, because in the long run, the longest amount of time is at least one factor of production is fixed. So at least one resource is fixed. But we could talk about a day. What's fixed for a day? What's fixed for a week? What's fixed for a month? What's fixed for a year? For my particular business, if I'm running a small photography shop out of my basement, or if I'm running John Deere and making tractors, there's a difference there. So it's the length of the long run is the length of time at which any resource can be varied, any resource can be changed, which means in the long run, all costs are variable. Remember that. So in the long run, all costs can change. Everything's on the table. Anything can vary. So this distinction is, as Sam said, a short run distinction, because in the short run we have some things we can't change that we're locked into. So fixed cost, variable cost. All right, so we got to know that part. Sometimes we deal with averages. So what do we do to get an average analysis going here? Take quantity and do what with it?
Divide everything.
Divide it. So we divide this to get the average total cost per unit. The nice thing about this, using our math, if I divide this side by Q, I got to divide the other side of the equal sign by Q as well. which gives me another formula that you have to have memorized, committed to memory, and that is that the average total cost of production is the simple sum of average variable cost and average fixed cost. All right. The most important cost is not listed here in terms of econ class. What cost is that? Marginal cost or opportunity cost. You're okay. Opportunity cost is probably more important than just the pure concept of marginal cost, but that they're embodied in each other. So marginal cost is the change in total cost divided by a change in an additional unit of output. We've got a little adaptation we can do, though, because we know how total cost changes. How does it change? Which one of these changes? Variable is the only thing that can change. This one's fixed by definition. So this is also equivalent to looking at the change in total variable cost divided by the change in quantity. Yet another way to figure that out. All right. Let's jump right into some problems. So look at the problem you got. It's the one with the list of costs. And you got the little table, yeah. Well, I guess both sides have a table. So the shorter one is that. So, how do we approach this one? Cook's Catering. For the past year, had the following statement of revenues and costs. Revenues, supplies, electricity and water, employee salaries, Dan's salary. Dan's always had the option of closing his catering business and renting out his building for $100,000 per year. In addition, Dan currently has job offers from another catering company for $45,000 and also a high-end restaurant offering a salary of $75,000. Dan can only work one job at a time. What is Cook's accounting cost, economic cost, and economic profit? All right. Accounting cost. Which one should we throw in? Let's just look at them. We can do the addition later. So we got the upstairs stuff of supplies, electricity and water, employee salaries, Dan's salary, and then we got these other options for him. He can rent out his building that he has. And then he's got these other job offers. What's the accountant going to allow? What do you got? Sam, number between 6 and 7.
6.5.
6 or 7. Good answer, though. 6 or 7. Pick a number.
7.
Brenson, what do you got for accounting cost?
Okay. For the accounting costs, I explicit costs that is written down.
In the table, name them off for me.
Supplies, electricity, and water, employee salaries, and Dan salary.
And Dan's salary. Okay. Everybody get that? Yeah.
The accounting cost is like which option?
What do you mean of
Like-
which option?
Like, are we doing his current job or the if he quits his catering business or?
Current books.
Okay.
Yep, current books for the restaurant. So Brenton says supplies, electricity, water, employee salaries, and Dan's salary. Everybody agree with that?
Yeah.
Okay, so grand total? 275. That's correct. All right, so another distinction that's not there that I want you to write down. Explicit cost plus implicit cost. Getting back to Chelsea's comment on opportunity cost. The full opportunities include both. So both of these things together represent opportunity cost. From an economist standpoint. Explicit costs are the ones that accountants usually deal with. Those are ones that are easy to see. They got an easy price tag. I bought something for my restaurant, whatever. So explicit costs are easy. Now those are still opportunity costs. We don't want to forget that. Why? What's the opportunity cost if I'm in the business of making these bags, or if I go buy this bag, since I'm in a restaurant doing somehow I'm a wholesaler, supplier, or something. If I go spend $14 on this bag and expect to sell it for $28 at my store, why is the $14 an opportunity cost? Because you give it up. You could have bought something else with the $14, but it's very explicit, right? We know what your other opportunities, you had $14 worth of other opportunities that you could have spent the money on. The more difficult one might be the implicit costs associated with attaining it. So did you have to take off time to drive to Olathe? You spent an hour's worth of time going back and forth. Maybe you had some explicit cost of gas. But you as a business owner, did you pay yourself? Were you on the clock? Were you not? So there might be other things to consider that are more implicit than explicit. All right, so all of those things represent opportunity cost. So the accountant's got 275. So A, just the things you said. Notice that it did include Dan paying himself a salary of 60. So B, economic cost. So we already know that we're going to want to add on to the 275 because those are the explicit costs. The big question then is to find the art form of economics adding what type of implicit cost. What do you think we should add?
Since it's the highest value alternative, we have one of the options is also the salary.
Okay. So renting of the building, so you want to add 100,000. Okay. Well, that's the question. What do we do? 15? Why do you say 15?
Because he's already making 60, so his opportunity cost would only be 50.
All right. So yeah, the extra that he's giving up is the 15 at the margin. So he's got an additional implicit cost of 15,000 to calculate economic costs, which now equal 390,000. All right, therefore giving economic profit of 110,000. So $500,000 worth of revenue. He's got $110,000 worth of profit. Now, what's he really taking home cash-wise? $225, right? So you go back up to the cash is what the accountant was calculating. And actually, we could throw in his 60 salary depending on how we worded it. So the company's making $225 on the books, accounting profit. He's earning the $60,000 that he was paying himself as part of the explicit cost of the business. So adding those two together is kind of his take-home cash, I guess, from looking at that. So why is it important to add this stuff and show that he has less profit than what we think? What's the economic logic there that why we employ that technique? Okay, so we don't want to lose the profit that he could be making. Okay.
He has that opportunity.
Yes, he has those opportunities. What else is key about this number? I'll give you a, yeah, I'm kind of talking about that, but I'll give you a hint. Those of you who had me before, this means nothing to Sam. It means stay, yes. And entry, possibly, right? So profits act as a signal to the other people in the market, as well as a signal to Dan, is our guy's name? Yeah. As well as a signal to Dan himself. So if this drops down to negative 10,000, he's still got a bundle of cash he's taking home, but he's missing out on other opportunities that would be more profitable. Right? So that's the catch of why economists calculate profits this way, to really help us decipher the appropriate profit maximizing decision to make. Do I just rent out my place and take another salaried position, or do I keep going? Right? So now profits act like a signal to Dan as well as possibly other participants in the market. Okay. Any other further questions on that one?
Question.
Yes.
How'd you get the 15,000?
The 15,000 came from the 75, which was the highest job he could have gotten. But with this, if he would have done that, he would have had to give up his $60,000 pay that he's doing now. So it's really a benefit of 15. So it's the difference between what he's paying himself at his current place for a salary anyway. So, and the logic there, by the way, would be, let's talk about that. I think that's an important nuance to this. Couldn't he just pay himself 70? Couldn't he just pay himself 85? There's money in the cash register to say, oh, I deserve a raise. I should get 85. Why? Where did 60 come from? Presumably. Where did 60 come from? Other opportunities to hire a manager to replace himself, right? So for his particular business, the particular set of skills for his job. Now notice the market for his particular human capital allowed him, according to the problem, to earn 75 somewhere else, but it was in a different place, different circumstances, blah, blah, blah. So presumably the 60 came about from saying, taking a hard look at my particular job, the skills that are needed for this, and what the market will bear. I can hire a replacement for myself for 60,000 is what was presumably determined, which is reading more into the question than what's there, but it's an important insight. It's another layer of opportunity cost embedded into the problem.
Yeah, I mean, would he be able to leave, take the salary elsewhere, and hire somebody else and still own the business at a higher profit?
If he could, let's work through that. So he leaves the business. He gets 15 only. He still needs the building at the current business, possibly, right? There might be other opportunities, but he could possibly leave. And then would he be 15 to the good?
Wait, so we're taking out the...
So the question raised is whether he could just leave and be better off.
Well, I'm saying still own the business.
Yeah.
And work elsewhere.
Right.
So you'd be taking the 100,000 out of interest, right? Because now he's not renting out.
No, I think the business would stay, and the business needs the building.
Yeah, but you're getting the 100,000 in revenue, though.
But he's still owning the building, right?
Oh, if he's renting it to the business. So it would change maybe from a implicit cost to an explicit cost. Is that what you're saying?
Like if he still owns it, but he's not working there.
No,
Yeah,
you might
'cause
just
right-
be subtracting the 15 because that's the cost of not renting the building out to somebody else.
Right.
So
So we'd be possibly changing this 100,000 to now a rent for the building, which is also important in the decision making, right? So pretend Dan's tired, decided he wants to go do something else. He's built up a business that seems sustainable. He hires a $60,000 person to come replace his job. He now charges rent to the business that he no longer owns, right? He's got a landlord cap on, right? Or possibly he still owns the business.
yeah, I was going to say he's the one.
Okay, so he could still own the business too, but as long as we've got these other opportunities on the table, profits will continue to signal something to us. All right, so 15,000. If he can replace it, is he 15 to the good, cash wise?
Yeah, yeah.
Sound right? Is everybody good and lost? I see some blank stares there. If he continues to own the business and therefore reap the benefits of the business, but he takes this other job, how does this stuff change? Is this still here?
No.
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 So if it's not here, this becomes 400 and, no. What were we doing? Adding or subtracting? We're
375.
No, we're adding. Yeah, right. We're adding these, subtracting it, yes. So 375. Making economic profit 125.
So if he still owns the business, why would he be renting the building?
It's just an opportunity cost. Now that then further, if economic profit drops enough, then he might be better off closing the business and renting out the building. If he can't make at least the profit, or if he can't cover his opportunity cost with the operations of the business, and that's what we're doing here, is we're including the rent essentially as part of the operations. If he can't do that, then he'd be better off shutting down the business and renting out the building, because then we know he'll make 100. He'll have the 100 grand. Okay. All right. So that's a little bit of a refresher on that. Let's go to the flip it over. So, Fields Forever, small farm that grows strawberries, sells them at the farmer's market, produces strawberries using 5 acres of land that rents for $200 per week, also hires labor at a price of $250 per week per worker. Table below shows the output of strawberries measured in truckloads and varies with the number of workers hired. Calculate the marginal cost of 1 to 5 truckloads. So I don't want to do the whole thing here, but let's do the marginal cost. Oh, I suppose up to 3. Let's just truncate this to 3. So we got labor. Put that up. We got labor and strawberries. Zero, 1, 3. And we get strawberries. We need the truckload. 0, 1, 2, 3. 0, 1, 2. What are you starting off with your next column? I'd say you need to add some columns here. Total fixed cost would be good. And what's total fixed cost running? 200. we got that 5 acres, whether we produce any strawberries or not, we've committed to that cost. Total variable. So $250 for one, right? And if we hire 0 people, it's 0. 3 people, $750. Add those two together. We start to get a total cost function here of $450, $950. And then finally, what the question asks for is marginal cost. Marginal cost associated with the first is how much? 250. So moving from this cost to this cost level. Now you got to be a little bit careful. Why can I just take this and say 450 minus 200 equals 250? What's legit about doing that under these circumstances? The quantity's going up by 1. That's right. So watch out for that though, because if this was 0, 10, 20, then the real formula, remember, well, I got it written here. Total cost divided by the change in quantity to put it on that per unit basis. So here it just happens to be going up by 1, so yes, we can just go like that. Next question, did we have to calculate this column like Rhiannon suggested? No. Good, right? Because we know that this is true. And you can see it come out now. 0 to 250, 250. 250 to 750, 500. Okay? All right, questions on that one? Marginal cost increasing or decreasing? Increasing. Look at that table again too. Marginal product. Under this table of numbers, before we leave it here, marginal product, diminishing or constant? Marginal product. Shifting gears on you. It's not asked in the question. Constant? Why do you say it? Marginal product. So I'm shifting gears on you. Look at these numbers. Is marginal product constant or diminishing? Now here's some constants and diminishing. Why did you went both ways? Why did you correct yourself? Why did you switch?
Because the number of labor force is increasing, but the quality stays the same.
Good. So if you calculate that out, marginal product is the change in quantity from a change in a unit of labor. And this one potentially could lead you to staying constant because you see quantity going up by an equal unit each time. But it's really, what do we got here? 1 divided by 1, 1 divided by 3, 1 divided by 7, 1 divided by 12, diminishing marginal product. Okay? Now, the reason I wanted to point that out is because sometimes I know the problem I went through in principles class, I had this going up by single units and then quantity ramping up different, not in a constant rate. So depending on the problem you're looking at, be careful that you don't think they all work that way, right? That all problems work that way just from a quick glance. Okay, next problem. This one ties back to the chapter we just left as well. Oh wait, no it doesn't. That's the next one after that. Which one are we doing? Yeah, I want to do the cost one first. The squared total cost equals, I probably should just have these labeled, but total cost equals 15q squared, that one. Yeah, with the two boxes, correct. So you've got a total cost function and a marginal cost function. Find the firm's fixed cost, variable cost, average total cost, average variable cost. So now you've got a functional form, but you're really doing this. So think about this equation, but you're applying it to a formula. Squared plus 8q plus 45. So what did you do for fixed costs? $45. So Q equals 0. So to solve for fixed cost, Q equals 0 to find total fixed cost equals 45. So that just collapses this thing down. You know you got 45 bucks. So again, I can't emphasize enough, the linchpin to the chapter a lot of times is that. Recognizing that issue with variable cost and fixed cost. Okay, variable cost. You got the other part of it, right? Now you could say that total cost minus total fixed cost, total cost minus total fixed cost equals total variable cost. Manipulate this equation around. That would be legit. I've got this function minus my total fixed cost, the 45. The 45s cancel. I mean, it's kind of a simplistic approach, but mentally that might be easier, especially if we get into maybe more complex functional forms where there could be some parameters involved or something else. So hang on this, the whole chapter, have this committed to memory. These formulas, know them. This is chapter 7. Okay, so yes, you're right. 15q squared plus 8q is the variable portion. Then we get into the averages. What do we got? Average total and average variable. Simply divide by q's. So average variable cost equals 15q squared plus 8q divided by q, which is 15q plus 8. Same thing for average total. Average total cost equals total cost divided by q. I'll just write this up here, 15q squared plus 8q plus 45 divided by q. Q plus 8 plus 45 over q. All right, so now you see where we're diverging from principles class, right? Principles class, I usually gave you that stuff, or we're dealing with graphs. There are graphs still that we haven't even gotten to yet. But we start having a specific functional form. we're doing the same math, but we kind of let the equation kind of roll out. We still got things as a function of quantity. All right, now marginal cost was given to us. Marginal cost equals 3q plus 8. 30q, thank you. Calculus people, see a connection between this and this?
Yep.
What is it? First derivative. So first derivative of the cost function is the marginal cost curve. Makes sense. That kind of might help with some of this later stuff here, but not needed. Find the output level that minimizes average total cost. That minimizes average total cost. Thoughts there? Think back to principles graph. Principles graph. We're measuring dollars here, quantity of goods here. What was the graph looking like? Had the bowl. I see the bowl. Which one's that now? Average total. Average variable is bowl shaped too and kind of converged in on it because the vertical distance between the two was average fixed cost. So that's average variable cost.
Is like the average total and average fixed cost of this are they're not curves, they're just linear functions.
Possibly. What goes on? I don't. These aren't curves on the average. Let's see, what do we got here? Average total cost. That's average total. So we got some curviness going on. We're missing one. The most important one, the economic one. Marginal cost. Where did it go? How did it live? The base of it, the minimum point. So I always had you guys put a big fat dot there to kind of help you graph it. Marginal cost cuts through the minimum point. It's J-shaped in general and cuts through the minimum point of the average total cost curve. Question B. Find the output level, Q, that minimizes average total cost. Set them equal to each other. You got them, right? Good. Marginal cost equals average total cost. There's your functions. Set them equal, solve for Q. Anybody got an answer yet? Q equals square root of 3, which equals 1.73. 1.732. Find the output level at which the average variable cost is minimized. What's that? Set them equal to it. Yep. Same process. This one turns out to be a little bit easier. Should collapse down to 0. All right, that is it for today. Homework for Chapter 7 will be due Monday, so if you want to get a start on it, we're pretty much through most of the material. A lot of this is quasi-review. Bring back these principles, concepts, and apply them, and I think you'll be doing good.